Welcome to this deep dive explainer on hazard and risk assessment. If you're studying for your exams in disaster management, think of this as your core review of all the essential principles. Let's dive right in. All right, let's just boil this all down to one central idea. If you want to manage a disaster, you first have to measure the risk. But how do you actually do that? That's precisely what we're here to deconstruct. Okay, first things first. Before we can go any further, we have to get on the same page with the language. Let's precisely define the foundational terms that make up the vocabulary of disaster management, because getting this right is absolutely the most essential first step. First up, hazard. At its most basic, you can think of a hazard as any potential source of danger. It's the event or the condition itself, an earthquake, a flood, a chemical spill. But it's also really important to classify them. Are they natural, like a hurricane? Or are they anthropogenic, which is the term for human-made, like a major technological failure? Understanding a hazard's origin and its characteristics is always step one in the analysis. Next, we have vulnerability. Now, this concept is so important. It's not just about physical weakness. It's really the sum of conditions determined by physical, social, economic, and environmental factors that increase the susceptibility of a community to the impact of a hazard. For example, a town with outdated building codes has high physical vulnerability. A community with high poverty rates has high economic vulnerability. And you know what? They almost always compound each other. And that brings us to capacity. If vulnerability is all about the weakness and susceptibility to harm, well, capacity is the exact opposite. It's the combination of all the strengths, all the resources, and the positive attributes that are available within a community that can be used to manage these disaster risks and build up resilience. We're talking everything from early warning systems to strong social networks and even local knowledge. So we've got our key terms down, but here's the thing. They don't just exist in isolation. Now we're going to see how hazard and vulnerability dynamically interact to create the thing we call risk. So take a look at this picture. Everyone on this truck, and I mean everyone, is facing the same external hazard. Let's say it's that brewing storm you see overhead. The potential threat is identical for every single person. But, and this is the crucial part, the risk is totally different for each of them. The driver, safe and sound inside the cab, has a pretty low vulnerability. The passengers, on the other hand, they're exposed in the back with zero protection, so their vulnerability is extremely high. So even with the identical hazard, their personal risk is just drastically higher. This is a perfect illustration of a fundamental point. Risk is not just about the threat. It's about who is exposed and how well they're protected. Now, this relationship isn't just a loose concept. We can actually formalize it into a really important equation. And this formula is basically the theoretical centerpiece for all risk assessment. It's how we move from an idea to an actual calculation. And here it is. The academic model puts it like this. Risk is the product of three variables. It's hazard, the potential threat itself, times vulnerability, the susceptibility to harm, and times a crucial third piece, exposure. So what's exposure? Well, it refers to the people, the property, the systems, or anything else present in a hazard zone that could potentially be lost. Now, what's so incredibly important to see on this slide is the math. It's multiplicative, not additive, and that changes everything. Because the factors are multiplied, if any single one of them gets close to zero, the total risk just plummets. So a massive magnitude 7.0 earthquake, that's a high hazard, poses almost no risk in an empty desert because the exposure is zero. But that exact same hazard in a densely populated city with poor construction, it becomes a catastrophic, very high-risk scenario. Risk is fundamentally contextual. You have to remember that. Okay, so we've got the theory, we've got the equation, but how do we actually use this stuff in the real world? Well, that's done through a formal, structured process called risk assessment, which turns all these concepts into information that can actually save lives. And that process is called a disaster risk assessment, or DRA for short. It's the systematic method, the playbook, for applying that risk equation out in the field. Its whole purpose is to inform critical decisions, things like land use planning, new policies, building codes, early warning systems, all of it with the ultimate goal of reducing harm. So, let's break down the distinct stages of the disaster risk assessment process itself. Honestly, understanding these steps is the key to understanding this entire field. And this slide gives us a fantastic way to visualize it, as a pyramid. See how it builds from the bottom up? You have to have that solid foundation of analysis before you can ever get to a comprehensive, specific assessment at the very top. Each layer is absolutely essential for supporting the next. So, the 4 key steps, you'll notice they logically follow our equation. Step 1 is hazard identification. Basically, we're asking, what could happen here? This means scientifically mapping out potential hazards, their location, their intensity, how often they occur. Step 2, vulnerability analysis. Who and what could get hurt? Here we analyze all those physical, social, and economic conditions that make people or assets fragile. Step 3 is exposure analysis. Who and what is actually in harm's way? We'll dig into that one next. And finally, step 4, the risk assessment itself, where all this data gets synthesized to evaluate the potential impacts and, inform what to do next. Okay, let's zoom in on one of those steps, a really key quantitative part, exposure analysis. This is where we figure out exactly what or who is at risk. And we can quantify this with a pretty simple formula. Exposure equals P times A. Here, P stands for the population or economic assets in the zone, and A is the size of the area that could be affected. So, for example, let's make this real. Let's say a potential flood zone that's our affected area, A, covers about 50 square kilometers. And let's say the population density, RP, is 200 people per square kilometer. Well, a simple calculation shows us a total population exposure of 10,000 people. And that number, that's not just an abstract figure. It is a critical input for everything from evacuation planning to deciding where to allocate resources. So you see, being able to calculate risk is absolutely essential. But it's really just the starting line. The real challenge, the whole reason we do any of this work, is to translate this data into action, building stronger infrastructure, creating smarter policies, and ultimately saving lives and protecting communities. That is the critical question.